Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Now in our channel we deal with different aspects of mathematics, physics, chemistry and biology and other related topics. So today we're going to look at a concept in chemical thermodynamics, and this basically is going to be a complementary topic on some of the aspect of thermochemistry that we have discussed in some of our videos. So I'm going to put a link over in the description box for that specific set of videos, and it's going to be in form of a playlist. So kindly check on it and try to, of course, link it with this specific one so that it gives us a comprehensive way of trying to relate these specific concepts. So in this sense, we are going to look at this particular concept of energy. And in us trying to define this concept of energy, of course, we're going to look at the relationship that is going to exist between matter and this aspect of energy that we're going to describe in various forms. So basically, we can be able to graphically, or rather in terms of algebraically, represent this aspect of matter, which we refer to as energy. So there are various ways in which we can be able to define this, but we can generally refer to the concept of energy as the ability. So we can give a short description of energy as the ability to do work. And of course, in this sense, we're going to see that this aspect of work is going to consist of various aspects, and we're going to consider the aspect of force, some of the scalar and vector quantities. So we're going to consider the aspect of force and direction, and of course, we're going to see that this relationship between these two are going to describe the concept of work. So basically, we can be able to define work as the product of a force times the distance. That is from the classical mechanics videos that especially we have done on motion. So therefore, we can be able to roughly define work in this specific sense. So therefore, we're going to consider various aspects of chemistry. We're going to find some variations whereby we're going to consider some cases for perhaps aspects like gases, whereby they are going to display a different property insofar as these variables are concerned. So therefore, that is what we are going to particularly look at. And we said in our discussion on the concept of course, kinetics, we said that there are various there are various forms of energies. And the first one that we can be able to give is kinetic energy, which we described as a form of energy that is entailing the concept of motion. So we are given a description for kinetic energy where we say that it's a product of mass and velocity. It's a product of the product of mass and velocity for particles which are under motion. So therefore, we can be able to describe kinetic energy in that form, which is a form of energy that can be described for particles in motion. And then we said there is another type of energy that we refer to as potential energy, which is basically possessed by bodies at rest. And then we can be able to describe potential energy of a body at rest as the product of its mass, the gravitational force acting on that particular body, and the difference between that stationary body, the level of that stationary body with respect to the ground. And that is going to give us the aspect of potential energy. And then in terms of chemical energy, there are various ways in which we are going to describe the concept of chemical energy. And this basically entails the energy which is realized due to chemical changes or chemical reactions which are going to take place. So in this case, we can be able to look at aspects of electrochemistry and other areas which we are going to have a relationship describing this specific kind of energy. And then we talked about the concept of heat energy. And the heat energy, in this sense, we have described the concept of exothermic and endothermic reactions, especially under the concept of course, thermochemistry. And in this sense, of course, this is going to open for us a window in trying to describe the concept of heat, especially in relation to matter in this specific topic that is going to give us the concept of energy. So from these various forms of energy, we're going to see that energy can either be described as in its active form as kinetic energy, as we said, or the potential form, whereby we're going to see that it's a stored form of energy. And there are various scientists who came up with ideas on trying to describe the relationship that exists between aspects of matter like mass and energy. And this one of them was Albert Einstein. So Albert Einstein gave a description of energy in terms of the product of mass and the speed of light. So he came up with this famous formula, which is describing this aspect of matter as energy is the product of mass times the speed of light, which basically where this m represents the mass of the particle under consideration, and then this is a speed of light, which is a constant, of course. In some literature, we're going to see it being given as this particular case, meters per second, given as such, or 3.0 times 10 power 8 meters per second, given as such. So this is a constant which is known, and therefore this energy is going to be given in terms of joules. So therefore, having that one in mind, we're going to use this specific formula later, but we're going to see that its dimensions can be described using various aspects. We have said that work can be described as the product of force times distance. And this aspect of work, we have said that is a description of energy, whereby we have said that basically energy is the ability to do work. So if we can be able to describe work in terms of force times distance, we know that force is a product of mass times acceleration in classical mechanics. So if we consider a particle in motion or a particle that is an active particle, then therefore we can be able to describe this in terms of mass times acceleration, and then times the distance. And we can be able to give dimensions for this. Mass is measured in grams, and then we can be able to have this one, acceleration in meters per second, and then distance is going to be measured in meters given as such. So we can be able to describe this specific, this acceleration is going to be measured in meters per second a square, so that is going to be s negative 2 given as such. And this is going to give us a product of the dimension of work given in terms of, or rather, given in terms of energy. So we can be able to describe this using this. We have said that energy is the ability to do work. So if a description for work is given as force times the distance, we can be able to have this force described as the product of mass times acceleration, and then we're going to give the dimensions for this, which is going to be grams, meters square per second square given as such. So that is going to be one of the dimensions that we're going to use in trying to measure that particular aspect of energy. And I've said that the SI unit is going to take the form of joules, and we're going to give this one as an initial given as J as such. So if you try to look at this specific description of the concept of energy, there are various terms that we are given, especially in the description of thermochemistry, which of course are going to assist us try to narrow down or confine ourselves to the specific concept of energy, and various terms which are going to be used. So the first one that we used was the system. And we said that the system is a particular portion of matter under consideration. And we were given a figurative description of this specific set for a system, whereby we say that this is going to consist of a system. And the surrounding part of the system is going to be referred to as specifically the surrounding. And that portion of the contact between the surrounding and the system is going to be referred to as the boundary. So the system, the boundary, and the surrounding together are going to form what we refer to as the universe. And these are going to be a description of various forms of the system, or rather various forms of this specific concept of energy that we're going to describe. So this is going to be discussed heavily, especially in the concept of thermodynamics, whereby we're going to see that, as I said, the system is a portion of matter under consideration, and then the surrounding is going to be a portion of that matter that is, of course, separating the system from the surrounding, as I've mentioned, and the boundary is going to exist between the system and the surrounding. And in this case, of course, we are going to consider the aspect of a transfer of energy. So if there's this specific boundary is going to allow the transfer of energy between the system and the surrounding, we're going to refer to this one as an open system. And if this boundary is not going to allow the transfer of energy between the system and the surrounding, this is going to be referred to as a closed system. And therefore, when matter can be able to transfer or rather, when matter can be transferred between the system and the surrounding, we call that one an open system or a closed one, as I've mentioned. So, in some cases, we are going to see that there are some illustration that we can be able to refer to as an isolated system, which is basically a form of a closed system in which there is neither mechanical nor thermal contact with the surrounding that is going to be given. So that's another version of these two specific aspects of our open and closed system that I've given. So if there is no communication totally between these specific two aspects of matter, then therefore we're going to refer to that one as an isolated system. So if the heat energy is going to be allowed to be transferred across this specific system and the surrounding, we can be able to just use a different illustration. So suppose we have a particular system given as such, and this is the surrounding. So if the heat is allowed to flow from the surrounding into the system, or vice versa, as illustrated as such, we're going to see that the changes such that the system and the surrounding are maintained at constant temperature. We're going to see that there's a specific term that we're going to refer to this system, and it's going to be referred to as an isothermal. It's going to be referred to as isothermal, so or isothermic. So therefore, this is basically a situation whereby the flow, the heat is allowed to flow from the surrounding into the system, or vice versa. And then we're going to see that during this specific change, the temperature is going to be maintained and at a constant value, and the change is going to be referred to as isothermic. So therefore, this is another term apart from the surrounding, the system, and then the universe that I've mentioned. So we'll be taking note of these specific terms that we're going to refer. So this, the change of heat energy which is being experienced between the surrounding and the system, while the temperature is being maintained at a constant value. So we're going also to see that apart from temperature, if the pressure is maintained at a constant value, then the change is going to be termed as isobaric. So this is another specific term. In case we come across the term isobaric, then this refers to the situation whereby the pressure between the system and the surrounding has been maintained the same if this specific changes over the transfer of heat energy is being experienced. And for last case, if the system is completely isolated from its surrounding, the changes that are going to occur are going to be referred to as isobaric. So they are going to be referred to as a diabatic. Temperature, whereby if the heat energy is transferred between the surrounding and the system, and then the temperature is going to be maintained at a constant value, then that specific state is referred to as an isothermic state. And then if the pressure is maintained while the heat transfer is occurring between the system and the surrounding, then that state is going to be referred to as isobaric. And then lastly, we have said that if the system is completely isolated from the, of course, from its surrounding, the changes occurring are going to be referred to as diabatic, given as such. So those are some of the terms that we're going to encounter in our concept of various forms of energy, as we're going to look at later in various aspects of the chemical thermodynamics discussions that we're going to have proceeding this. So in a summary form, I've said that there are various ways in which we can be able to describe this concept of energy. And basically, it depends on what aspect of matter we are taking into consideration. And of course, I said that there are various forms of energy which are going to be described as either active or rather, they are going to be described as either active or stored form. And therefore, I gave an example of kinetic energy, which is a description of energy in motion, and then potential energy, which is a stored form of energy. Now, in this particular case, I said that energy basically is the ability to do work. And we can be able to describe energy, mass, and relationship in terms of matter, whereby we say that Albert Einstein provided the relationship that exists between the matter and the energy by giving the product of mass and the square of the speed of light as, of course, variables that are going to give us the concept of energy. And from this, of course, we can have different relationships which are going to describe the various forms of energy that I've mentioned, especially when we are trying to consider from the kinetic aspect of matter in the, of course, the macro and the micro level that we are going to see. Now, from this specific aspect, then therefore we can be able to describe energy of a system using various terms. And I said that we are going to consider a portion of matter which we are going to refer to as a system. And this portion of matter is going to be separated from its surrounding by what we refer to as a boundary. Now, in this specific case, there's going to be interaction between the system and the boundary, in a sense that there's going to be transfer of matter between the system and the surrounding, and therefore in that specific state we refer to this specific type of boundary that is existing at this specific level as an open boundary. So if there is no exchange of matter or communication between the system and the surrounding, then therefore we refer to this boundary as closed. And if, of course, there's no communication or contact between the system and the surrounding, then therefore we're going to refer to that system as isolated. And then we say that, of course, there are various ways in which we can be able to describe the change of energy between the system and surrounding, whereby we say that if the temperature, there's an exchange of heat energy between the system and the surrounding at constant temperature, we are going to refer to that state as isothermic or isothermal, as I mentioned in this specific case. And next we say that if the pressure is maintained where the heat energy, there's an exchange of heat energy between the system and the surrounding, we're going to refer to that state as isobaric. And then lastly, if we say, of course, there is the aspect of this energy whereby if the system is completely isolated from its surrounding, the changes that are occurring between these specific cases are going to be referred to as adiabatic. And that forms our last bit for this specific concept of energy. We're going to have various videos which are going to assist us, of course, create a comprehensive relationship with this. Of course, kindly check in our description boxes for various videos on thermochemistry and others which are related to this, and they will assist us, of course, have a comprehensive picture. For now, guys, by God bless. Catch us in our next video.